My name is Thomas Degn, and I'm Associate Professor in Industrial Design at the Umeå Institute of Design at Umeå University in Sweden. I would like to present and talk about human-centered conceptual product design as an exploration tool to imagine and enact the future of medical devices. So just to give you a little bit of insight to where I come from, I come from the Umeå Institute of Design. Here we see a photo from the sky over the Umeå Arts campus next to the Umeå River. Our department is relatively new. It was founded in the late 80s. It's a small school, 130 students, but super international from both Sweden, EU, and outside the EU. We only focus on industrial design, but we do it on a basic, advanced, and PhD level. And I am active and responsible for the Master of Fine Arts program in Advanced Product Design. I take in students once a year, roughly 12 students per year. We have roughly 10 applicants for each spot, and we are mainly taking these students in based on artistic samples. So here we have some screenshots from some portfolios I've been viewing earlier. So these are skilled industrial designers on a BA level of the equivalent that I take in. And we provide them with a studio-based learning environment where they each will get the spot where they can sit and work during a study year and learn and interact with each others and tutors and so forth. We have a tradition of collaborating with professional external partners. We believe that's beneficial also to bring in the world outside into the classroom. We pride ourselves of focusing on users and their real needs, and in order to do that, we need to really understand them. So we try to follow them and study them as much as we can. The facilities, studios, labs, and workshops are available to our students 24/7 during the 10th month of studies. And we're also happy to say that the majority of our students that graduate from us are employed within the industrial design community. And despite our small size, we are internationally acclaimed design education. And we believe it's a unique study environment and experience for the ones who are able to come and join us up here in the far north of Sweden. And despite, again, our small size, we have been ranked 9 times as #1 on Red Dot's ranking list over the most award-winning design schools in Americas and Europe for the majority of the times during the 11 years that they have done so. So we are extremely proud of that, of course. And we have done a number of projects with focusing on healthcare or medical technical solutions. So we have looking at pre-hospital scenarios for a couple of times, looking for paramedics. What needs do they have for specific everyday situations, or what would happen if they are at a mass casualty situation where multiple and different patients has to be treated, has to establish a triage overview, and so forth. We have also gone into the hospital, and a couple of times we have collaborated with the Department for Premature Babies, which must be the most vulnerable user group that I have encountered, but also the needs of the caregivers that care for these 24/7, and of course also in this particular case, the concerned parents and loved ones that also get in contact with both solutions and the environment that the equipment and users are in. And just last study year, we completed a project looking into future intensive care monitoring, of which I will show 2 of these results as a part of this presentation. But medical technical is not the only thing we do. We also do other business-to-business opportunities, first responders, building and construction, forestry, industry solutions, consumer design, healthcare, and so forth. And when we do so, we try always to look from the perspective of the user. And there's a lot of knowledge connected to whatever user group it is, if he or she is a professional or consumer, and what part of the world or business area. And we can read up on that. We can do so much with the information that is available, but the experience of how it is to be this user or this professional, that is something that we need to understand. So we try to get us up close to these people as we can, and maybe ideally try to experience it ourselves. I think it's easy to understand that a firefighter has to carry heavy equipment, and we can see it, we can hear them say that, but I guess it's when we try it out ourselves, we realize how heavy it really is, just as an example. And we try to position our students in this knowledge pool, and through tutoring and guidance and so forth, we try to have them access the most relevant part of this knowledge amount that is out there. And we try that to include both students and external stakeholders in this. So this is not something we do in solitude, we do it as a group. And we do it because we want our students to understand that they're designing for someone else and their problems need visions and dreams. We want our students to experience complexity and how to handle it and navigate through it. We always ask our students that we want them to identify what they think are relevant design opportunities within the specific scope that we give them. And when working with real people, it is difficult not getting empathy for these and their situation. When we are working with people, you always have the opportunity to get inspiration and feedback that are relevant. And when doing so, as the progress goes along, you hopefully also get validation that you are on the right track, or there was something that they liked in particular, or something that worked or didn't. And we also believe that going through all of this, there is a potential for innovation, combining known needs with new technology. And we believe that industrial design is a kind of a perfect fit to explore all of this. So of the 3 projects I want to present here today, starting from left to right, the 2 first ones are from the same term project, and then the last one to the right is a thesis project that took place during the spring term of 2021. So if we start with the first 2 ones, they both saw the light of day in a project called Future Intensive Care Monitoring that we did together with the company Yetinge. The project scope was to explore the potential for new design solutions for future intensive care monitoring by considering the known needs for vital signs monitoring of different kinds of patients going through different types of therapy and recovery stages at an ICU. And that was basically our jump-off point. This project took place during a 10-week term project from start to finish. The red graphics indicate the visits that we had at the Umeå University Hospital. The orange ones were 2 of them are canceled, but the planned visit at the clinical training center at the hospital, we'll see some imagery of that. And the black blocks were kind of professional designer input from the design company Design It. So it was a very intense 10 weeks, as you can see, from start to finish. And we started off the first week by visiting at the cardiothoracic ICU, even despite, or even under the ongoing COVID epidemic, we were able to go there in smaller teams to see the hardware, software, patient transport, the facilities, the limited aisles where the patients are being treated, and we could get as up close as we could. The only thing that was hidden for us were the personal information from a particular patient, that, as we see here, that is what the nurse is hiding with her hand. Otherwise, we came as close as we absolutely could, even under these extreme situations. So that was extremely valuable. Also to get an understanding of what are the technical level and to get a professional expert input, we could send a small group of 4 students down to Yetinge, Stockholm to visit their office. And I'm going to show you a small video showing their trip down there. with a little bit of sightseeing as well. For all of us who are still in Umeå, we could also visit the clinical training center up at the Umeå University Hospital, which is facilities that are made for education, where professional clinical staff can train people coming in from the county on on new procedures and equipment that they utilize at their healthcare facilities. We rented a room that was kind of set up to simulate an ICU to the best of the abilities. And there we met a number of different professional nurses from the hospitals who came and shared their insights and what they think would be worth addressing in these situations. And it was also an opportunity for the students to come up close and later on revisit and use the same facilities to test out ideas. But we'll see examples of that. And of course, like most of us, there was a lot of Zoom and team meetings throughout these 10 weeks across both practical and safety reasons. But here at UID, each of the 4 student groups got their own group room where they're both under kind of controlled and safe circumstances could collaborate and work together and try out, build things in the iterative design process of that we go through by trying out things, sharing things, testing it, 2D, 3D, back and forth, digital, analog, and so forth. And here are some pictures of some of these group room, how they look like. So it was trying things out, going physical, going from theory to practice, 2D physical, 2D visual, trying out materials and cables and whatnot, just trying to act it out and have a discussion about it. So if we're jumping ahead, the final results were 4 concepts where I will be showing 2 more in detail, the top right one, the array, and the lower left one, the SOVA. And if we start with the array, and that is, as the title says, a proposal for the next generation of ECG. So one of the takeaways that this group took was that future patient treatment involves more movement around the bed by more healthcare professionals. So again, freeing up space and mobility would probably be a good thing. And of course, we all also know that these ICUs with a lot of screens and buttons and bleeps and blobs and cables, wires, all over the place, can be quite intimidating and maybe even confusing for the ones who knows what this equipment is. So could that be simplified? So when this group started to look into the different sensors and monitoring opportunities, they quickly kind of zoned in on the ECG, more or less basically because there's so many cables and wires linked to the ECG as we know today. And there's some opportunities that if we can make something simpler there, that will probably be quite valuable. And they looked into kind of the monitoring, the processing, and the displaying, and had that as kind of 3 different sectors that they should look into. And they started by summarizing the input that the nurses had given them, and also tried to create a kind of a very simple persona to capture all of this, so the user insights would not be forgotten. And then they started exploring, like designers do, going visual, trying things out, crazy ideas, have something to talk about. And they came to the conclusion that there will probably be something called, they called it a dock. There will be the sensors on the body, because to get a reliable readout, there would be sensors on the body. You can do a lot with camera technology, but they thought that in order to make this credible and that it should be accepted, there would be something that needs to be placed on the body. And then how to get that wirelessly transferred to whatever monitoring device or system there would be at the particular healthcare facility. Again, they also got physical, so they did over 20 different mock-ups, iterations of different setups. The ones that were kind of more defined are here, and they were evaluated based on 4 criteria, and the 2 that kind of stood out were one they called the Nixon 2 and the Array 2. And both of these were taken to the next step and tried out at the clinical training facility. I'm going to focus on the Array here, but here we have the students trying it out under kind of as realistic facilities as we could give them, with a real patient's bed, screens and tubes on each side. And the Array, where the students could see what does it really mean, how are the cables placed, what does that mean for the bed blanket, the pillow, and all the others, the other cables that are going back and forth to the patient, so to say. Does it make sense? They took also both concepts, here we see the array, and showed it to the healthcare professionals that we were in contact with. And one of the takeaways that they took from this was that we want a solution with as little cables as possible, a very powerful quote. And that made them hone in completely on the array. So if one would kind of compare the ECG as we know it today with 5 cables and the potential for spaghetti syndrome, that there's a hard connection from the patient to the equipment around it, and that also limits the patient's ability to move as he or she are getting more maybe able to move around by themselves. And the array would address all of this by being much more simpler, also making it easier for the patient, for the caregiver to wash and take care of the patient. And later on for the patient also to move more freely, both in the bed and maybe also up in the bed and maybe outside of the bed. So the array system would have the dock, a unit placed stationary next to the bed. It would have the ECG cables with 5 clips on the patient, and there would be a small receiver unit that in theory could be plugged into any existing equipment at the ICU. But I will let the students themselves introduce their concept.
Do you remember this cable mess? Our concept replaces the current 5-cable ECG with a single wire solution called the array. By reducing the amount of cables to a minimum and simplifying the workflow, we help to improve the user experience for patient and healthcare professionals. And yes, it's wireless.
This sensor array gets placed on the patient's body and feeds the monitor data wirelessly into the current system, so that it can be displayed next to all the other vital signs on the patient monitor. A small receiver plugged into the already existing setup enables this wireless data transfer on an encrypted protocol. The array itself consists of a head that houses the battery, the antenna, and a satellite interface, and a single cable sensor array that can be arranged freely on the patient's body. This device is designed to sit on the human skin. Its minimalistic shape makes it not only easy to clean, it also simplifies daily routines for caretakers and declutters the patient's appearance. The attachment of this device follows global intensive care standards and even guides healthcare professionals during this routine. They start by simply placing the head in the shoulder area and attach the other leads on the remaining electrodes. The clip's scissor sliding mechanism helps to fix them in a gentle way without applying pressure to the skin or even hurting the patient. The cable length can be adjusted by sliding them into the designated holders. With a nicely arranged cable setup, the device provides more comfort for the patient and ensures an optimal fit for each body shape or size. As soon as all the leads are in place, they transmitting the monitored data, all while sustaining the patient's ability to move freely unhindered by cables. On the head of the device, sensor connection and the battery status can be checked. The battery can be exchanged easily while the setup remains placed on the patient's body. During cleaning or special treatment, nurses deattach the ECG array and place it in the charging dock, which is fixed next to the patient's bed. Here, the sensor can be stored when it's not in use and gets charged simultaneously.
So just a quick overview of the ECG unit on the body, the head with the LEDs. And the idea is that each of these LEDs have an independent cable running to it, but all of these are kind of isolated in one housing protecting them. And the idea is that you can pretty much buy this as a kind of a complete system and plug it in to the existing monitoring solutions and screens that you will have at your specific healthcare facility. And we have to say that this project received recognition here in 2021. In this case, 3 different design competitions so far with the array concept. The second concept I thought I would share with you is called SOVA, that looked into soft vital signs monitoring, and we'll get to what that is. So some of the research that this group picked up on was that a large number of the patients that has gone through an experience at the ICU have severe mental problems. Also one of the takeaways was that it's much more important to look at the patient, him or herself, than looking at the screen. It's all about the human being laying there in front of them, and you can easily lose touch of that. So again, what were the main stressors as an ICU? What the question that the students said to them, and of course it could be pain if something happened to you or you've been undergoing surgery. It can be an anxiety. You are concerned with what will happen, or maybe you're unsure what has happened. And it can also be a lack of sleep. You can maybe get into a bad cycle where you sleep in the day or lying awake at night, and that can cause some concern. And research say that a lot of the communication that happens regarding what pain the patient is experiencing are unsuccessful, maybe because the patients are not able to fully communicate or whatever the reason may be. And also a little bit the students try to elaborate on how the stressors kind of can affect the mental health of a patient, and if there's a starting point there and you are, maybe in pain or you get no sleep, you can develop delirium, and through that maybe sedation and medication can be introduced, which might result in a longer stay at the hospital to complete the recovery cycle. And there might be a vicious cycle going on here in worst case scenario. So again, what if you could do it in a different way, that if something is being detected, that medical staff could intervene earlier, maybe by having a look at or an understanding of what the patient is going through, or if the patient maybe can be better at communicating this, and in the best of worlds, maybe reduce the hospital stay. So a reduced hospital stay in itself would be a goal. A higher patient capacity would also be good, because that's a bigger rotation and maybe also lower cost per patient, or the ability to be more efficient. The students took out time to conduct additional interviews, not only at Umeå, but also 4 different places around Europe. And 2 of them I want to highlight here. We see from Tartu, where they use a whiteboard to list up communication to the patient who are in let's say, what you call hospitalized for a longer period of time, so there could be specific information available for him or her. And also talking to the healthcare team at Umeå Hospital about whatever basic practice that they have in place. So the students felt that could be an opportunity for introducing something a bit more advanced. But again, the conclusion was today's vital signs are more hard. We kind of were introduced to them in the previous project that we all know of, and definitely these are important and they should still be there. But what if an additional world of vital signs could be the more softer ones, and that we together with that could combine them too? And the students try to kind of figure out where maybe some of the known manufacturers of equipment that monitors vital signs, where they were placed, and maybe saw an opportunity for Singer to move over to the softer part of monitoring vital signs, and that is where the SOVA concept comes in.
Imagine waking up in the ICU. You don't know where you are and what happened. You might not be able to speak or move. You don't feel in control of yourself. It is an extreme, unfamiliar and mentally stressing situation. Many patients suffer from severe mental problems like delirium or post-traumatic stress syndrome during or after their ICU stay. How might we address the mental problems in the ICU sufficiently to improve the recovery time and long-term mental health? SOVA consists of 3 parts. The sensor on the head monitors the patient's pain and sleep patterns. The patient interface with the camera monitors the patient's activity and supports the communication. The interface for the healthcare personnel visualizes this information. For instance, healthcare professionals can be informed when a patient shows signs of waking up after surgery, so they can be there for support. With the help of eye tracking, the patient can control the interface no matter what kind of physical condition the patient is in. Patients will be able to receive information but also point out pain or any other issue or need they might have. This can be done in interaction with the healthcare professionals but also by oneself, depending on the cognitive abilities. SOVA monitors several aspects of the mental health continuously, and the healthcare personnel can be informed as soon as the patient shows signs of mental degradation. This will empower the healthcare professionals to provide a more personalized, humane care, increasing the long-term patient well-being in the ICU. SOVA supports common diagnostic methods like the ICU CAM for delirium, but also allows for advanced continuous assessment of the mental state even without a nurse being present. The interface can also be used to provide the patient with relevant information like a schedule or a personal message. SOVA, Soft Vital Sign Monitoring and Patient Communication.
So as we saw, the SOVA concept consists of both the nurse's interface, the patient interface, the screen in front, and even in this particular version, a patient sensor on the patient itself for optimal vital sign tracking or soft vital sign tracking. So there are technology out there that could help to monitor the brain activity and maybe pain level. Even without that, with camera technology that we know from different conference systems that would be placed in the screen unit on top of the patient would be able to provide a lot of input, especially if the patient is about to wake up in the middle of the night. Looking at the camera technology just a little bit quicker, so there will be camera and eye sensor units there. So later on, if the patient is awake, that he or she can navigate the cursor on the screen with the eye movement alone, in case they're not able to talk as a part of their treatment. And the idea is that the nurses could have a good overview of all the patient on the ward, which one are maybe haven't slept, who's sleeping, who shows that they're in pain, and who seems that they're quite content. And also with the screen interface and by having the eyes as to follow the cursor on the screen, you could also try out on what kind of mental state that the students are in. Are they in delirium? Are they confused? Are they able to answer simple questions? And that could maybe also be an indicator if they needed a little bit of special attention. One could use gamification to literally challenge them and maybe also make sure the time goes by having a little bit of fun activities. And overall, the nurses could get a good overview of the different kind of soft vital signs that the patients have. And here we kind of see an overview of maybe the main menu. And as the video showed, maybe there could also be a little bit more specialized personal information that pops up on this screen, depending on how long the patient is hospitalized and also maybe the state of the particular patient's condition. And this project, just like the one before, also received acknowledgement in major design venues, and they even got a special mention in the Brown Prize 2021, which is of course quite an honor. The last project I thought I would show you was a thesis project by a Chinese student, Shui Li, who did it in collaboration with Lerdal Medical, a company that he had interned with before, and he is currently working for them right now. And the project that he looked into, he called CANA, and it's about self-directed CPR. So this is something outside of hospitals, but is related to healthcare overall, and I thought I would squeeze this into this presentation as well, and hope you will enjoy it. So as a Chinese, he was looking into the out-of-hospital cardiac arrest statistics, which are very high right now. So over 500,000. per year. And on a daily basis, this happens a lot. Apparently, China is the country in the world that has the highest level of this due to the population, and the survival rate of this are quite low for various reasons, both the ones we know of in the West and also others that are more linked to maybe the culture in China. And like so many other countries, the population are aging. Lifestyle diseases and so forth that comes with it is something that they are also experiencing. And the CPR implementation could be higher, some of the statistics that he found. And what is it? Well, I guess we all know that during a cardiac arrest, time is of an essence, and the more who can assist, or the quicker a patient who is experiencing this, or a person experiencing this, the quicker they can get attention and help, the better it will be. So it's about minutes. Shuai did additional remote interviews with stakeholders in China, and his how might we formulation would be, how might we provide an efficient and flexible remote CPR training solution to encourage more laymen to learn and improve their life-saving skills? How could that be done? How could you introduce this to more people in a big country like China? Jumping a little bit ahead, he developed 3 different concept directions that he thought was of interest. The concept 1 was kind of the CPR family, some little bit like a board game, something that you can kind of play around with at home. It may be cheaper, you might own it, you might get it sent, whatnot. The other one was a more flexible thing you can take with you, maybe it was for someone who can be an educator and teach others. And the concept 3 was far more virtual platforms where maybe multiple learners could be involved with 6 people attending maybe remotely at the same time. So there were different kind of directions. He did a little bit of a quick evaluation, which of these would be of interest. And although that maybe the center one got the largest overall response rate, it was the CPR family that he believed fulfilled more of the key criteria the best. So he decided to go with that one. So we had these early sketches about how could this maybe be made of cardboard. Can you do something that is a lot cheaper, a lot simpler, a lot lighter than what we know of today with the plastic dummies? Whereas Lærdal are also very known for their Annie doll for CPR training. So, but he was fascinated with the idea that it could be additional cheaper materials. So he did a lot of physical mock-ups to try out how would this actually work, the folding process, the sizes and so forth. And he went through, combined that with UX exploration with phone and augmented reality. And there would be something with simulating the bags, and there should be something you might touch with your lips, like a mouth, like we see in the gray 3D printed parts. So he brought it into one complete whole that he continued with. And he got feedback from different people trying this out. Could this be assembled? Can you use a pillow to actually get the softness, just to simulate a little bit that there's a kind of a chest there? It's not exactly the same tactical feedback if it would be a real human being or maybe a $1,000 mannequin, but maybe it would do the trick. So you just get the feeling of the process, the tempo that you need to follow and the sequence. And so he tried this out, and here we see some visualizations on how he imagined that maybe with a standardized mobile phone that you have with you, with the right programming you activated, you can actually start to interact, and using softwares and watching oneself and some graphics, get some feedback if you're doing something the right way or not. So he wanted to combine augmented reality with artificial intelligence, built-in cameras, and electric microphone to also use the sensors in the phone to kind of detect if the user is doing things the right way, and trying to see what can you do with this technology. Here we see some of the augmented reality explorations that he did just using off-the-shelf software, just to see, can you see something on the phone that would make the experience when interacting with a simple cardboard model more realistic and rewarding. And that ended up with the final result that we see here, that is called Canne, as he imagined that it could look like. It consists of cardboard modules that you can assemble. Here we kind of see them drawn out for us. He imagined that it could come kind of in one package, that you could get sent it to you, could order it, you could maybe get it by your employer and bring it with you back home. You would unpack it, there will be instructions included, printed on it. There will be a kind of a code, CVR code, that you could scan in, and it would activate whatever software you need on your phone. You would kind of fold it out a little bit like a board game. This are probably on the floor for optimal use. And here we see the chest part that then would be assembled with its own instructions. And there you would insert a kind of a paper lung that will come along in the package. You would have rope fixation as a part of it, and there will even be a kind of a head and a face that you would need to assemble, and you will connect the lung to that and a certain mouthpiece. And here we have the complete package. And the last thing to add to this would be one's own smartphone that you would have here. And then you would position yourself opposite to this. And there will be certain exercises that one would go through. Kind of basic, what are the things that you should consider? Is the patient unconscious? Try to figure that out. Just to make sure. And the other thing would be kind of what would an emergency call actually look like or sound like.
120 operator, what is your emergency?
I have a medical emergency. There is someone who can hardly breathe and lie on the street.
Where is the location of the street?
We are at the south gate of Renmin Park on Jiangguo Road. Please send an ambulance. Oh, it is 17th Jiangguo Road. We are in front of the Green Gate.
Okay, what is your name?
I'm Shalini.
Don't hang up.
So the idea is that one could kind of go through the process. So if it would really happen, so all of this would be simulated, but if it really happened, you would be trained on giving the correct information to the first responders that you will talk to. And the next step would be, what do you do next? So here you will get indication on the chest compression, and that you will get guidance in the sequence and the tempo. And when doing so, maybe this could be the interface that the camera will track you. You'll get a kind of indication of the depth. And when it came to the ventilation, that the camera and the software will pick up on the test person as he or she inhales blood into air, blows air into the dummy. Sorry. And here we see more. And again, at the end, there will hopefully be some kind of validation that one did better, and maybe also some tips on what one can do better the next time in order to improve. And here we see some screen overview of the graphical user interface that it could maybe look like in the final version. So, but I will show you a small video where Shuai introduces his project himself.
In China, more than 540,000 people die from sudden cardiac death each year. The survival rate of out-of-hospital cardiac arrest is less than 1%, lower than the other countries. CPR training, as recommended, is the most helpful and effective implementation to save cardiac arrest victims. But the CPR implementation in China is extremely low. So how can we provide a flexible and efficient remote CPR learning solution to encourage more lay people to learn and improve their life-saving skills?
Hey, my name is Shuai. Let's talk about saving more lives for out-of-hospital cardiac arrest in China.
The main problems of low implementation of CPR in China are that the lay public has less motivation to join a CPR course because of fewer opportunity, interests, high cost, fast-paced lifestyle. The less qualified full-time instructors, short supply and overworked skilled physicians are other significant barriers to teach life-saving skills. Besides, the CPR training equipment, such as mannequins, is too expensive and the amount of it far limited for this vast population with an old training mode. The outcome is called CANI. It provides a self-directed CPR learning experience for the lay public. A cardboard basic life support learning kit that allows lay people to practice CPR, such as cardiac arrest identification, chest compression, and ventilation by themselves. The CANI application on the smartphone can significantly enhance the learning experience by simulating cardiac arrest scenarios and emergency medical services, providing real-time feedback of compression and ventilation, as well as encouraging lay people to join the final examination and granting a certificate. CANI provides an ecosystem to motivate lay people to learn CPR at a low cost. It saves time and medical resources and has minimum requirement for the learning environment.
CANI can be accessible to all the regions where people have a smartphone, not only in China, but some more developing countries need CANI to help save more lives. If you are interested in my thesis and want to know the story behind CANI, please come to my virtual space and chat.
And Shuai, just like the two other projects, also got a lot of recognition. He was the Swedish national winner in the James Dyson Award and went to the final selection. And he was also one of only 10 winners in the Brown Prize 2021. And that was a kind of considerable financial award in connection with that as well. So we, of course, extremely proud of him that he could do a project like this for his thesis. So just to sum it up, here we see the three projects that I've gone through. I hope you enjoyed it. I hope you found it inspiring and interesting, and hope that you saw the connection that we try to make with both understanding and experiencing the particular situation at hand, both to understand the users, but also to understand it ourselves by trying things out as a part of the development process. So with that being said, thank you for your attention. Here you see my details. If there's anything you're wondering about, please feel free to reach out to me. Thank you.